That's disgusting.
You know what I'm talking about? No.
Okay, good.
No, wait, no, don't fucking talking about.
Star Trek way cooler than Star Wars.
Actually, I don't
Star
know.
Trek.
My dad used to watch that.
Star Trek predicts the future.
Stop.
It's the science of Star Trek. Okay.
You know, shut up. 'Cause you don't
So
know.
yesterday was a study hall. Nothing was covered. That's it.
Except our bodies. What? Our bodies are covered. What are you talking about?
We need to figure out A through E, which one is true. There's more than one that's correct. So letter A is talking about the vertical asymptote. So if you don't know this right now, you need to know that vertical asymptotes come from denominators. But we'll have to factor and
Oh, so
simplify.
funny.
Denominator. When I look at this, I see that both of these can be factored. So I would factor the top to x plus 1, x minus 1. And the bottom, I'm thinking what multiplies to negative 6 and adds to positive 5. Yeah. So a lot of people have a question about where wholes come from, Kaylee, and it's right here. When you factor and you have the exact same factor up and down, you can cross them out. So the new function that I'm working with is x plus 1 over x plus 6. And this factor that I crossed out creates a hole. A hole in the graph. So I would do x minus 1 equals 0 and solve it. And I would know that there's a hole in the graph at x equals 1. So that's letter D. We know letter D is true. So now I'm going to focus here on this simplified expression equation. Vertical asymptotes come from denominators. So I'll say x plus 6 equals 0 and solve it. And negative 6 is a vertical asymptote. So I know that A is true. And I know D is true.
So we know one of the vertical asymptotes is x equals negative 6. Could we possibly say that B is now false because it has a positive?
Yes, B is now false. Because there's only one vertical asymptote, negative 6. That was important here on content. Kaylee, do you have any idea where horizontal asymptotes come from? How do we decide? No.
Oh, you know. Yes, there is. They come from exponents.
We're going to compare the exponents, top and bottom. So, to determine the horizontal asymptotes, we'll compare exponents. So the exponent at the top is 1. And the exponent in the denominator is also 1. So I would say that A equals B. And when A equals B, what's the horizontal asymptote? Gabby? We do the coefficients for the number in front of the exponent. Correct. You do the coefficients is what I would say. The horizontal asymptote will be y equals 1 over 1. So letter C is true. I only talked about x-intercept on the day and two truths and a lie handout. Does anybody recall how do we figure out x-intercepts? Torian.
we plug it into the numerator, and if the total comes out 0, then we know why it's going to be 0. So that's the x-intercept.
So this is at all x-intercepts, y equals 0. So if I have to determine an x-intercept, one thing I can always fall back on is putting a 0 in for y and solving. If I were to solve this right now, I would multiply both sides by x plus 6. I knew that. Which is still 0. 0 equals x plus 1 and then the negative 1. So it would also be true. So x-intercepts come from numerators because if you put a 0 here, like this is always going to happen, the denominator cancels out and remains 0.
So the only one false would be correct. There is an imposter among the answers.
You stop.
Alright, get out that 2 truths and a lie, and I will give you credit for it. I need to see your work. And then I'll also put the notes up so you guys can start.
What I do the project.
Which is absolutely ridiculous. Yeah, I know.
You saw him sign up for the project, didn't you?
You should have known your boyfriend. How are you gonna get mad? Exactly. It makes 0 sense to me. And he also tried to take a bite out of my pizza at lunch. I went absolutely bonkers. Yeah, he didn't smell it. My pizza. He literally grabbed it and was like, dude.
Hey, why would you say that?
Also because I got an argument.
You cheated on your boyfriend?
You guys, that is recording. Stop your conversations about other people.
Uh-oh.
Not necessarily, it's not hitting it maybe on your voice, but it could be, so that's just. Yeah, keep it if it wasn't. Like, let's not talk about people who aren't in the room. Right? Just in the room.
Yo, you started your project like
No.
I don't have time for this.
Alright, so we're going to solve equations. You can see this. It's an equation with 1, 2, or 3 fractions. And not just any fractions, like fractions with numerical denominators. You've solved equations like that for a long time, but fractions where the denominator has the variable. And these problems can look lots of different ways. So they don't always just match the same method. You have to really use some critical thinking. So it's solving rational equations. This is just an equation that has a ratio of polynomials in it. The first star is really important. You don't have to copy this word for word, but just think about this. It's going to be easier to solve if the fractions are eliminated. So the process is really, your goal is to eliminate fractions, and then you have an equation like you've always had, without fractions. So, in order to eliminate fractions, you have to multiply all 3 parts by a high polynomial that will cancel the denominators. So you eliminate fractions by multiplying both sides by the LCD, or whatever the least common denominator would be. So you're going to reduce and solve the remaining equation. So if your fractions did not disappear when you multiplied everything by an LCD, you've made a mistake. Your goal is to make the fractions disappear. Sometimes you get a solution out that's undefined. You have to check for that. If I solve this whole thing, and my answer was -3. When you plug -3 in here, it creates an undefined fraction, so you would actually reject that answer. So you have to check and say, well, does this work if I put it back in the denominator? Actually, we just started this new material just now. So. All you missed was bell work. I've been hearing that lately. Way to go, Dean.
Bro, what? No.
Here we go. Okay, so yeah, I need to email these things. Something needs to change out there.
What?
All right, what is the LCZ? So, I want fractions. So I an LCZ that we get rid of all three of these fractions. So I'm really focused on x plus 3, 6, and 18. The least common denominator, Polly. If I was picking a common denominator here, Emily, please stop your conversation. What would I pick? Yes. Oh, really good guess. Really good guess. You're very close. You picked 2 out of 3, right? No, but I'm gonna focus on the 6 and the 18 as separate from the x plus 3. I don't try to merge those together. Torian, what do you think it is? 18 is a common denominator between 6 and 18. And then I also have to put in the factor x plus 3. So don't try to put them together. If there's a number with an x, just keep it with an x. So now, that I've picked this, and you'll get good at picking it after we do more than one, I'm going to multiply both sides by this. So I'm going to show you, when you write these problems, I recommend that you spread it out, like really wide. So I'm going to do 18 parentheses x plus 3 times the first fraction. And then I get a plus sign. I'm going to write it again. 18 parentheses x plus 3 times the second fraction. Then I'm going to write it again. 18 parentheses x plus 3 times the last fraction. So after you pick your LCD, and that just comes with practice, that's not something that you just wake up knowing how to do. You gotta practice it. You write it next to every part of the equation. And then we reduce. So we're going to reduce diagonally. So we look at each little bit here separately and reduce them accordingly. So here, what we'll reduce is the x plus 3's. And all I have left to multiply is 18 times 4. 72. In the second bit, 18 and 6 can be reduced. 6 goes into 6 once and 18 3 times. So what I have left to multiply would be 15x plus 3 equal sign. In the last bit, the 18s can be crossed out. And what I have left to multiply is 23 and x plus 3. And just like that, you have an equation with no fractions. So from there, you're using previous skills to solve. So go ahead, distribute and solve.
What was that?
Oh, this is just distribution. Sometimes, yeah. Sometimes it's fine, but that's just distribution.
Knock it off.
So what would be the least common denominator?
We picked 18 because they both go into 18. And then we had to include this factor. Yes, sorry.
Is it possible this fact 15 times x plus 3 as a term in itself?
Yes, you can. You could have 8x plus 3.
So now when you do this division, you're working with smaller numbers.
Definitely. I love that.
Oh, I see.
Yeah.
Oh, yeah.
Solve.
What?
We're actually going to find what x
I was
is right
telling
now.
you about it.
So 72 and 45 is 117.
Fine. Okay, I actually kind of understand. Crazy, actually.
It's nice to be able to clear fractions. Like, very cool. I'm nervous about some of my numbers here. Can anybody verify 117 in here? Yeah. Okay. And what's 117 take away 69? 28.
Oh.
Divide. That's all. No graphing.
Are you guys eventually with this?
We already finished graphing.
Oh, there you go.
That graphing was complicated.
I
If
just
we
lost
put it, if this is equals y, then you guys know how to graph it.
Like, this is silly.
So if you were to put 6 in right here and add these, it would be 23 over 18. It would work. So you found what x is.
Like that
You
confuses
can't
me.
cross multiply with two fractions. If it was one fraction, you could. No, there's something there. This is right from your textbook.
You just multiply everything by 18 to x plus 3.
So least common denominator. Oh wait, no, it's not. It's not. I'm just kidding. But
They give you the least common denominator. So 1 is the least common denominator.
bruh.
No, I'm going to change this because I can't. I'm going to change this. I hope you didn't write it down. That problem. Let's try 7 over 3 minus 3 over x minus 5 equals 19 over 12. Very similar question. What do you think it is? No, we came up with that. That was not given. You could probably look at it and come up with it right now. 60, huh? No. So this one was 18 in x plus 3. This one is 12 in x minus 5. No. The reason I'm picking 12 is because 3 goes into 12.
Yeah, what about?
doing the X
It doesn't matter. That's why you pick x minus 5 along with it. So it's 12 parentheses x minus 5. Multiply that to all three parts. Can you pull that? You have to pick every factor. So when we were adding fractions, I said your common denominator has to include every factor in the fractions. So your LCD is a high number that not with the x's, that the numbers without x's can divide into. So 3 goes into 12 and 12 goes into 12. And then you also include anything with x's.
So you're just doing. Okay. That makes sense.
Yep.
Is there ever gonna be one like?
Yes.
Okay.
They look way different. Like some of them are gonna have like 2 parentheses. Some of them are gonna have variables with exponents.
You kidding me? Middle straw. Who's? Oh.
I'm gonna reduce before I multiply. So 3 goes into 3 once, and 3 goes into 12 4 times. And then I multiply whatever's left. So I have 4 times 7 is 28. And I'm just going to keep that x minus 5 for my next step. Yes. And actually that is the most difficult thing, is to add and subtract and solve. And here the x minus 5s cross out, leaving 3 times 12. And over here the 12s reduce, leaving 19 times x minus 5. Correct.
I thought you had to get all the denominators the same, but it's not.
That is what I would use if I was getting all the denominators the same. A fraction, yeah. It's 95.
Yeah. Negative.
You finished, Paige? Yep. What's negative 95 plus 176?
No, either. Not either.
So you had did you do it like that? You subtracted 28 groups? You got negative 9 of them? And plus 45? Negative 9x plus 45?
Yeah. Do.
That's 4.
It's just sore. I don't know why though. I literally didn't even do anything. Ooh.
Alright, let's jump it up. Jump it up a bit. Let's try this one.
Oh my gosh.
It looks a little different. You know, there's just no like regular numbers.
Well, there's.
Yeah, let's factor it.
Nothing. I'm smocking on myself.
Just the denominator. Leave it. Only factor the denominator. If the denominator can be factored, factor it.
Oh.
Yes. Until the very end. So we're going to factor this denominator if possible. So now it's 2x, x plus 5, minus x squared minus 10, x plus 3, x plus 5, equals 3 over x plus 5. So our LCD is x plus 5 and x plus 3. Every factor has to be in the LCD. Yes. It could be 10, you know. It won't be in this side.
No.
Yeah.
I'm not the science dude.
So I'm going to write the LCD next to every term.
I understood it. Now I don't get it. Matthew, I don't need your input. Thank you. I appreciate that. Thanks. Okay.
So I wrote what I did. Both parentheses, I wrote it next to all three parts. And this time the x plus 5s can cross out. And all I have left is 2x and x plus 3. And here, both of them reduce. Jacob, you got this? You finish it? No. Subtraction is challenging because you have to distribute a minus sign. Be careful about that. Who's got a question about how it was reduced and crossed out with the two parentheses? So I have to subtract this entire expression. Just be really careful about that. This minus sign changes all three of these signs. You have to multiply that. It's like a -1. Yep.
Oh.
Oh no. That is. This is bad news.
Where did you get that from?
Bad news.
I combined my terms. And then I saw I had x squared, so with quadratics I know I have to equal these 0. And now I have to solve this. and it doesn't factor. So you have to use the quadratic formula.
Oh my god.
But after you learn it in Algebra 1, it's present for all of your other higher degree functions. So that's why it's a tool in Algebra 1, because it has shown up in almost every chapter, because once you get here, if it can't be factored, you can use the
It's
formula.
shown up in.
I'm still confused on how you got 2x plus 4x.
You mean x squared? Did you distribute this? You got that? And you said you got the negative one thing. So I did 2x squared minus x squared, because those are like terms. And that would be 1x squared. And I had 6x and x is 7. Oh.
Yeah, I got that, but then how did you get?
Move everything over so you have a 0. For quadratics, yeah. Not for linear functions, but if x is squared, you need to set equal to 0.
What's the creeper noise?
So only if x is squared is that
Well, factoring is quicker. If you could factor it, you would factor it. Quadratic one, yeah.
So what did you do on the one before it?
Mm-hmm.
What did we do
You
on
used to get it?
practice problem number 2?
It didn't have an x squared.
Oh, so we just solved it.
I didn't learn that until this year. Well, maybe it's because my
It's actually a big part of geometry.
all of our algebra.
Yeah. I'm not going to put any more problems up. I'd rather help you with the 4 problems that I assigned in the workbook. Did anybody work ahead and know that there's one that's
No.
So look up on the workbook page. When you see, and I'll pick the most difficult one to do with you. I assigned 1, 2, 5, and 6. I'll pick one that looks different than what we just did.
I actually did it. Yeah.
Matthew, I kind of understand it too. Matthew, I kind of understand it.
So good.
So unsupportive. Oh, here we go. What are you talking about? What? No, you were like, it's not that hard. Yeah, you were like, it's not that hard. No, you were not. You were literally like, it's not that hard.
Max, what do you think the LCD will be here in our homework problem?
-5. Y -5.
Max, is that the
That's the right page. Oh, shit.
Max, this is appropriate in school, actually. The problem
That's my point. So this problem, the number 1 was at least common denominator before x.
correct?
Which way? Oh, shit. 1, 2,
don't think any of these pages have enough comments for that. Huh? I found one of my workbooks. No, I just found one of my workbooks. Yeah. I saw 36. 36? That's a lot. What chapter is that?
What's 12 times 4?
How many chapters are in like our curriculum? That's what I'm saying. I don't think I've ever been in a class and like finished the whole book. It doesn't happen. Absolutely ridiculous.
And then we had like a whole month where we didn't Easter laser.
Oh, yeah.
My sister has.
He's a good teacher.
He is a good teacher.
He's just strict. He's an army guy.
Yeah.
Like ex-Purple Heart.
You're from Colorado?
Yeah.
No, I didn't know.
I remember when you went to my school.
My favorite kind of teachers are the ones that are also like coaches. Like, I should tell you about like stuff. Yeah, I think I do like stuff like you know some flyers on as much. Absolutely. Weightlifting is still the best possible. Which one is he? I don't. Did you see that?
Yeah.
Just.
I do.
It's a lot considering there's only 2 classes of everything.
Yeah.
The ratio.
That is true. People went to like after we got out of our charter, which is like they went to like I used to go to Parish in Peru and everybody's kind of like no one else really cares.
My kid probably went to Southeast too because the kids that come out of there are usually going into East I don't know anyone who came to PCS that.
Number 5 has a special solution.
You should look at it and think, well, what if y was 7? Would it be true? And it would be. What if y was 10? Would it be true? And it would be. You can put anything in. It's true for all real numbers.
How do we know that it's true for all real numbers?
Right here. When the variables cancel it out. I'm gonna pretend it.
Yeah. How did you get X? What? This is what I got so far. Number 1, I don't know how you got X over 16. I don't know how I got X. Thank you. Look, I'm right here. Number 1.
I love them.
Where did I get a Y from? Why did I put a Y in there? Oh, so there's a Y with a 4. No. It's not messed up.
Just the X.
I love it. I love it so much.
Would you also cross an X out?
The LCD is 2 parentheses X minus
on the
How did you get the two?
when you cross x up x two, so it's x squared.
How would you get the 2 in front of the x minus 1?
What?
For the least common denominator.
Yeah, so that's two. You have all the factors.
Oh, we have to take in the answer.
Yeah, you have everything.
I thought it was just the
I love this stupid little ball.
Where'd you get maybe yeah, that's what I was doing. Not x squared. What was your 5 answer again? That is funny answer. Are you kidding me right now?
number 1. Okay, number 6.
My bad.
I'm telling you, stop.
It's not good for your soul.
My soul doesn't get
It's never too late to turn it around. Never too late to turn it around. Absolutely. That sounded so like emo. I was
Holy shit. What is with you in that chair?
How do you get one of your
Get a comfy chair.
I can't sit.